So hello and welcome to me going over the formula assignment number 3, which is the absolute value solving assignment. The first two are pretty straightforward. You just set up two equations, set up for 6 and set up for -6, and then you solve. They both work. Make sure you check them and they come out to 6. This one, same thing, 30 and -30, make sure you check. This one, you're going to subtract 3, then you set up two equations. Now, when you come down here to number 4, what ends up happening is you subtract 3 and you get 6, and you do get some weird answers. So let's talk about what that means. If I were to, take a look at this problem, the first one is 6, the next one is -6. I subtract 5 and I get 1. You divide by 5, you get a fifth. It's weird, but it's okay. And if I subtract 5 here, I get a -11, and if I divide by 5, I get -11 fifths. Now, the problem is kids get scared of these fractions, but if you distribute this 5, which, by the way, you're allowed to distribute inside of an absolute value, just not outside. If you put this 1/5 back in here, 1/5 times 5 is 1. So if I plug 1/5 into this x, I get 1 plus 5, which is the absolute value of 6. And the question is, does that equal 6? It does. And then when I put -11 fifths in here, I get the absolute value of -11, right? Because the 5 and the 5 on the denominator cancel, as we've talked about before. That's why we did those domain restriction problems. Look, 5 times -11 fifths. That's why we did division in the previous assignment. They just cancel out. All right, no need to worry about a domain restriction here because there are no variables, but that's why we did those problems in 1.2. So I take -11 fifths, I put it there, and I get -11 and then plus 5, and that gives you the absolute value of -6, but the absolute value of -6 is 6. So they both work. And then you would put them in order and use curly brackets. So if you have this answer is correct, but it's not really algebra 2 enough, right? You need to put it in order and use curly brackets. Now over here, the very next problem, you cannot distribute, not allowed. You end up dividing by -4, and I just want you to think about this. We talked about this in class. You end up getting a half x plus 2 is equal to -2. Think about that. Now, if you want to solve the whole thing, I'm going to tell you right now, both answers will be extraneous. Why? The absolute value is distance. It can never equal -2. The answer is no solution. You're just done, right? You don't have to show work, and that's a rare thing in a math class. You don't have to show work for that problem. You have to show this work, but you don't have to do it. If you did, they both would be extraneous. You cross them both out and say no solution, or you can take that shortcut. So what do I do if I have variables? Nothing changes. So here I have 3x and -3x. I do all my solving. I subtract my 1, I subtract my 3x, I divide by my negative, I get 1. Here, I have to set it equal to -3x, so I subtract my 1, I subtract my 3x, I add my 3x, giving me 5x, and I get another fraction. But in this case, the fraction doesn't work. If I take -1/5 and plug it into here, I get -2 fifths, and -2 fifths plus 1 is 3 fifths. But if I put -1/5 in here, I get -3 fifths. Is the absolute value that's always positive, is it going to come out to -3 fifths? So that answer is extraneous, making your answer just 1 or curly bracket 1. On the next problem, they both work. You just have to check it. There's no way to know. You have to do it and check it. But please be careful when you do this problem that on the second problem, the first one you just set it up, but the second one, notice I changed this to a positive and I changed this to a negative. You got to do both. So then you just solve, you subtract 2 to both sides, you add 2x to both sides, you reduce, you get -2x, you get 2, you divide, you get -1. Same thing here, but since this side changes, it's a little different. Subtract 2, get -6, add 2, get 6, divide by -6, you get 1, and they both do check. Now, how do they check? If I put 1 in here, -1, I would get 4. 4 plus 2 is 6. If I put -1 in here, it becomes +2. 2 plus 4 is 6. The absolute value of 6 is 6. If I plug 1 in here, I would get -4. -4 plus 2 is the absolute value of -2. And if I put 1 in this side, I get -2 plus 4, which is 2. So is the absolute value of -2 equal to 2? Yes. And then I would put them in order in a curly bracket. Now, on the back, please pay attention to the very first question. You can't distribute, just like I showed you, and you divide, and this will flip to greater. So is the distance that's always positive greater than a negative? That's infinite solutions. That's probably the most difficult problem to get if you're not really analyzing your negatives. You really got to stop and think about those negatives. So let's do just a regular problem, see what happens. So a regular problem, you isolate the absolute value part, meaning you get rid of the 5, and then you set up one problem that's greater than 1, and then one problem that's -1 but less. Make sure you're doing that, or you might get the notorious two arrows going the same way thing, which is always not good. Okay. And so once I solve those, here I subtract 1 and get 0. Don't be afraid of 0. Divide 4 into there. That's okay. You get 0. Over here, I subtract 1, I get -2. I divide by 4 and I get a half. 1/2 is fine on a test. I'm going to say that very loud. You need to be able to do that. And the reason is, if you were to check 1/2, what's 4 times a half? It's 2. So this would be -2. -2 plus 1 is -1, and the absolute value of that is 1. So it even checks. So we're going to go ahead and we're going to put them on our interval. At 0, we're going to the left. At -1/2, we're going to the right. Please do not draw little hanging arrows where you have this stuff like this. You need to draw a barbell in between them. And then we have our answer, which is an and. So again, not in order. It's not okay to put an and between these two things. You got to put it in order, -1/2 and x is less than 0. But I want you to think about domain and range, which we did back in assignment 1. If I were to scan this going from left to right, watch. Beep, stop. Again, watch. Beep, stop. So this answer is good for algebra 1, and I'm filling in some gaps that you had maybe from COVID year. But in algebra 2, we actually write that answer as beep, stop, interval, use parentheses. Okay? So here we have an or one. Let's see why. We subtract 4, we divide by 3, we get 1. We set up two equations, one with greater than 1, one with less than -1. Don't forget about that. Then we add 8 to both sides, giving us 9, and divide by 2, 9/2. Here we add 8, get 7, divide by 2, get 7/2. And the 9/2 on a graph is going to the right, the 7/2 is going to the left, and this is an or. Again, it's not an order, so it's 7/2 or x is greater than 9/2. But watch this. Do you remember the graphs that we did in the first assignment that looked all curvy like this? And we would do beep, stop, beep. Look here. Beep, stop, beep. So what that means is that we have to use an interval from -infinity, right? Beep, stop at 7/2 with a bracket, and then nothing, 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 and then beep to 9/2. I just noticed that dot should actually be more like right there. So anyway, hopefully that's good for you. So they need to be in interval notation. You connect with a union. Union actually means or, and you use a solid square bracket because we have an equal sign, as opposed to over here where you use a parentheses because we have open circles. All right, so let's take a look at this one, which has an extraneous, because this one, if you don't realize it's extraneous, then you think that there are two arrows going the same way, but one of them doesn't work. So we set up two problems. One is with 5x minus 6 and the less than sign. The other one is to reverse that to a greater than sign and do minus 5x plus 6. Then you subtract 2 on both sides. You subtract 5x on both sides, and you divide by -2, flipping the inequality. So the inequality flips here, but it also flips here because I divided by a negative, and that's one of the rules for inequalities. If you divide or multiply by a negative, you change the inequality sign. So we have x greater than 4. Now here, when we divide by 8, we don't have to flip it because when you add 5 to this side, you have a positive number. When you divide by 8, you get a positive. It doesn't change the inequality. Now you might say, why did I cross it out? Well, what happens is you actually have another interval here, right, going that way. But if you actually check it, watch, this is so important. The checking never goes away. If I check 4 in here, I would get 12 plus 2, absolute value of 14. And then if I put 4 into here, I get 20 minus 6, which is also 14. The 4 is valid. But if I put 1/2 in there, I get 3/2 plus 2, which is 5/2, right? So 1/2 times 3 is 1.5. We'll just do decimals. I don't think that's actually the right number. Let me try again. So if I put 1/2 in here, I get 1.5 plus 2 is 3.5. And I take the absolute value of that. But if I put 1/2 in here, I get 2.5 minus 6, which is -3.5. Again, classic absolute value. It's supposed to be positive. That's extraneous. So I just take it off the graph. So the answer is x is greater than 4, and that's for algebra 1. But look for the domain. Nothing, 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 beep to infinity. So in algebra 2, we have open circle parentheses 4 to infinity. Well, I hope this helped, and I hope that is going to make your homework go a little easier